Eliot will be continuing with the similar topic. We'll be talking about securing IoT device, focusing on Wi-Fi. And this is the second time Eliot has come to Connections. Last time he talked about what's the role of manufacturers in the IoT space. And those slides and the videos are also available in our website, so go and check past proceedings if that's of your interest. And in fact, the topic also would have, is there a side meeting planned? More things are getting discussed in ITF 103, so this is interesting. And also, we want to thank Cisco for sponsoring and continuing their supports. So thank you for that. Let's welcome Eliot.
Thank you very much. I have a question to start off with. I like questions. How many people were at the meeting last year at Infosys? All right, yeah, that's pretty good. How many people work for Infosys? I'm just curious. Anybody from Infosys here this time? Yeah, I couldn't manage all the way across town, I guess, in the traffic. All right, well, first, thanks, Michael, as well for that great presentation, because I'm going to build on everything you just presented. Let's see here. Or not. I don't think this one's working. Now it is. Okay. 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 I'm such a technologist. So, Michael already covered this, but I'll just say, in a nutshell, why is IoT different? Right? Where's the keyboard? Right? This is an actual Philips Hue. Where's the keyboard on it? Can't actually enter anything in there. That doesn't work so well if you want to actually type in credentials for, to get on your Wi-Fi network. So, when we talk about IoT, and Michael covered a bit of ground here, as did our keynote speaker in the morning. We have all sorts of different things that are connecting. It's interesting is that, what's the commonality between all these things? Anybody want to hazard a guess? Anybody? AI? I'm sorry? AI? IPv6? Yeah, he wishes. Lee's gonna. That's Lee's talk tomorrow. Tomorrow? Yeah. Okay. Yeah, he wishes. Me too, actually. So actually, the only commonality that I can think of is IP, and maybe if we're lucky, maybe TCP. But I wouldn't bet on it. Probably just IP and UDP, and maybe not even that, right? But for my purposes today, I'm not going to talk about things relating to Bluetooth or Zigbee unless you want to talk about Zigbee over IP, because I like talking about IP. I've been doing this a while. And, for whatever reason, I've got IP on the brain. IP on everything, as they say. So, last year when we were talking about manufacturer usage descriptions, what the manufacturer needs to do. Michael actually here has done a lot of work on this too. We are going to have a side meeting on onboarding at the IETF. I'll ask this question, sadly knowing the answer. How many people are going to be in Bangkok? Yeah, a few people, which is good, not enough. Unfortunately, the side meetings aren't well covered in terms of remote participation. That means we have to use the thing that IETF likes to use the most for communication, which is mailing lists. So we'll talk a little bit. I don't actually have them on the slides, but I'm going to stop the presentation a little bit, and we'll talk about the mailing lists that we're covering this, okay? So today, I'm focusing more about the first topic. What is this thing? All right, this is about onboarding devices. I'm not going to talk so much about who's responsible for it, although that's an important thing that enterprise administrators need to understand. What access does it need? That's what we talked about last year. And we're well along on that conversation. And is it doing what it should be doing? We're going to call that a startup opportunity. Okay? So this is all about onboarding. What are the steps that need to happen when you onboard a device, when you onboard a thing? You pull it out of the box. Okay. Now, okay, that looks a little squished. Okay, the device learns which network to join. This is wireless onboarding, right? So what's the SID Can anybody figure out how to type the SID into a device that doesn't have a keyboard? Okay. Then we have to provision the device to trust the network. Michael talked a lot about that, and we'll go into a little more detail. And then provision the network to trust the device. Okay, that also has to happen as part of this process. And then you're good to go. Woohoo! Right? Okay, so here's like a little bit of a PowerPoint, let's pull out smart art slide. We start at the bottom, right? What's the minimum thing that we need for a device to actually be able to communicate when we're talking 802.11? Right? You have to have a correct network selection occur. Okay, what's the thing that Michael and Max and other people have solved? All the other stuff. So we got to back up and figure this question out a little bit better, right? Which is good. I mean, all the other stuff helps with this one. We're going to see how that works, okay? So Michael mentioned a voucher. Here's what it looks like, right? This is right. I don't know if this is the whole thing, but a voucher is a Yang artifact. Yang is the schema language that we use at the IETF to describe, to model data. People may remember MIBs and SNMP. We've moved on. Yay! Okay, so here's the flow that actually you have when you're doing the basic BRSKI. Okay, we talked about pledge. There's the duckling right up there. Let's see, here's yeah, look at that. There's the pledge. That's the duckling. Okay, here's this thing that's the manufacturer server that Michael was talking about. Okay, everything the pledge comes out of the box. The only thing it knows is the massa, right? The switch and the registrar are part of an enterprise infrastructure. We have to come back and talk about what that means in a consumer space, because I did say enterprise, but I work for Cisco, and we cater to enterprises, so I guess I don't care about consumers, except that I am one. So what happens, right? And this is there are several different versions of the basic flow, but the first thing the pledge has to figure out is how does it find the registrar? That's its first step. In this flow, I'm using MDNS as the means to do that. That's one way. There's another way called grasp that you can use as well. But let's assume you've gotten through that step. Okay, now I'm going to go ahead and use TLS to talk to the registrar. Right, I'm going to initiate a TCP connection and then start TLS. And then we establish what we call provisional trust. It says I'm going to trust this communication, assuming that by the end of it I was able to validate that certificate. If I can't validate it by the end of it, I got to throw all the state that I gathered through that communication away because it wasn't safe. Okay, so now I'm going to generate a voucher request. Somewhere along the way, the registrar gets to say, I do or don't want this thing on my network. Oh yeah, that's an important part for an enterprise, right? And it might forward that voucher request along to the manufacturer saying, you ever seen this thing before? Is this a really nice guy or is it a counterfeit? Right? Is it something that's been hacked? Is somebody trying to masquerade as one of your devices in order to steal all my secrets? And the massa might say, oh yeah, that's one of mine. And the other thing it might say is, and oh, by the way, are you allowed to have it? Doesn't have to. It could sign every voucher that comes to it and says, okay, that's it. It's nice that you came to ask me. Yeah, that's one of mine. I'll just sign. Could do that. I expect a lot of people are going to do that in the beginning. And that's great for wired. Okay, so what happens? The voucher goes all the way back to the pledge, and the pledge now has a reason to trust the registrar because what it has is the trust anchor that it can use for that purpose. It's great. Okay. So the next step that Michael talked about was enrollment over secure transport. That's what it looks like. Enrollment over secure transport for our purposes. Now, the nice thing is, if you already have the TLS connection, you might just use that, right? And essentially you do a simple enrollment request, you get a cert back, and now life's great. Okay, you're able to communicate on the network, and all this works fine in wired. Okay, that's wonderful. And by the way, we're thinking about how to do this in ways that we can condense the whole notion. which is to say, cram all that into what we call EAP, Extensible Authentication Protocol, which is really nice because it has the added feature that a lot of wireless 802.11 stacks have a lot of EAP support already. Maybe not exactly the correct EAP to do all this, but pretty close, right? There's a lot there, okay? And so this is abbreviated. It's not exact as to what's in the draft, but this is a nice innovation on top of that. I think one of the key things I'd like everybody to think about is, the big challenge here is how do you provision that headless device, that keyboardless device, and the innovation behind that is all around the voucher. And architecturally speaking, what I'm expecting is that notion, the voucher, the thing that you prove back to the device, that mechanism is going to evolve over time. That's the area of innovation. It's key. The people who did that, it was great. It was a great collaboration between Michael, Max, and a guy named Kent, who works at Juniper. So yeah, you had all sorts of people working on this from from a bunch of different companies, all realizing that there's innovation that's happening there. So think about that voucher, because it's going to change, I think, over time. It's going to evolve to what we need it to be as we get more experience. So what's the problem with wireless? Okay, so suppose that Masa just signs everything, right? And I'm seeing two networks now, company A, company B. I'm going to try company A first. Oops, there's no internet connection, can't do anything. Oops, that's one problem. The second problem is I might have accidentally joined company A's network just because the Masa said, oh yeah, I know you, that's great. Okay, so now I'm on the wrong network. Company B's gone looking for me, but they don't have anything in their logs. There is a way to go search the Masa, assuming that interface is available, but we haven't standardized that part yet. And anytime you have to say, go search for something you lost, you've increased operational complexity, so we don't want that either. And we also need to deal with the fact that that's a problem. I'm bringing up a new building. It doesn't have its internet access yet. Oh, what does that mean? Now I can't bring on those new devices yet? So we have to solve for that too. And these are a bit of a challenge. So we have a couple of things that we're thinking about. This is the core of what I want to just talk about today. Well, maybe, just maybe, what we need is a little bit more information to solve for which network to join. And maybe, just maybe, we'll call that a key or something like that. And we've encoded it in like a QR code. Maybe we haven't even done that. Maybe it's just a text string. Maybe it's an 8-digit string or whatever. Right? So now I have something that I physically have read off, okay? And I'm going to provide that back into the device. Somehow or another, I'm going to prove it to the device, or I'm going to prove it to the Masa. Either way, I'm going to prove that I physically know that this network is the right network to join because it's mine. Okay? And I know, and I'm the right guy to have it join because I'm giving you this proof of possession. So the one way to do that, right, is to first scan in the label. Then we're going to generate, let's see, yeah. First scan in the label. Then when this guy plugs in, it's going to generate a normal voucher request. It'll have found the registrar. We'll take that, we'll take these two items, we'll combine them and send it to the Masa. And the Masa can say, oh yeah, there's proof. He had this thing. This guy's generating the voucher. I know this guy. Here's the proof of ownership. And here, I don't need to know anything more than that this is the right password for this guy. Okay? Or the right key for that guy. All good, I'll send the voucher over. Great. Another way to do that is to pass the information to is to still scan in the label, still generate a normal voucher request, but pass back the key to the thing, and let the thing do the test and say, oh yes, I know my own label, right? And this guy actually, all I have to say is I recognize the label, I recognize the password here, I'll put that in the voucher request, pass that to the Masa, and the Masa says, okay, I see he's recognized that there's proof of possession, I'll trust him and sign the voucher. And then there's option 3. look, Ma, no masa. Okay, so this is the case where instead of relying on the manufacturer's service, what we're simply relying on is proof of possession, right? So the voucher is still generated, right? But I have the proof of possession key. I'm going to send back this voucher with something that's hashed with a hash of this thing. And if I do that, then the thing will say, okay, I'll believe you, you're the right guy. So a couple of things about threats here, right? First threat is the registrar is a bad registrar. Okay, that's one thing. The second thing is this thing is trying to steal this key. Right? The way you solve for the bad registrar is that this key has to have been inputted into the registrar. If it's not there, it's the wrong registrar. The second thing is that these keys have to match. And the registrar and the registrar is going to need to do a little bit of logic around this too. So we have some work to do there. All right. Let's see here. For the people in the back, you might want to move up for a moment. There's a lot of information on this slide. Drew's going to put it on the website, and this is basically a brief summary of all the different mechanisms that we've talked about. I want to just point out a couple of things on this slide, okay? The top lines. WPS, right? This is where you push the button on some home router, and then you push the button on some device, and a key exchange occurs. That works okay in the home, except it's massively insecure. Okay? If I want to steal your device, all I have to do is write something that speaks WPS, and it'll go to my network, not your network. Nya, nya, nya. Okay? Another mechanism that we're exploring is just use the serial number as a key. We're exploring it. I'm not sure I like it. I don't like overloading security componentry like this, and the serial number tends to leak like a sieve, and so somebody can steal your device if you end up leaking the serial number. There's another something that the Wi-Fi Alliance has done called Device Provisioning Protocol. It is similar to this slide here, right? The difference is that there's no voucher, and in terms of proof of ownership, you don't have that. You don't always have that here either, by the way. You don't necessarily have proof of ownership here. All you have is proof of possession. If the device fell off the truck, you don't get it. You can, if you want to do proof of possession and test proof of ownership, you need the MASA. This is the thing that says the device didn't just fall off the truck. Okay. There are a couple other issues with DPP. It uses non-standard encryption, which is a problem too, and it solves a problem at a different layer. It actually solves a problem at more the IEEE layer. All right. So I said, I've gone through these scenarios as to how to find the right network. You still have to round robin through all the networks you're hearing to see, is that the network that I need to join, and see if you succeed or not. The IEEE is the only place where we can short circuit that, that path a little bit, and so there's some work that could be done with them there. The IETF's not the only standards organization playing around in this space. So I want to talk a little bit about, the challenges that I think we face, right? This here, WPA2 and EAP, that's a footprint right there. But if you're doing 802.11, you're probably doing this. Okay, add on top of that symmetric keys versus asymmetric keys. Asymmetric keys, that means there's some manufacturing complexity involved, right? You have to have these two keys. Certs, anytime you're talking about certificates, that's yet more code. And not only is it more code, but if you're using X509 certs, it's a lot more code. And that means that your footprint is going up. And if you're thinking about those things that Michael was talking about in terms of devices that just get thrown into the concrete where a bridge is being built. I'm sorry, that was our first speaker is talking about that. You want to measure the stress in concrete. Those devices are meant to cost, 100 rupees, right? Try fitting stuff into 100 rupees, right? In terms of your cost of goods and services. The manufacturer side, right? You got, if you're going to generate labels, that's some complexity. But if you're not going to do that, and you're going to try and keep track of who bought what, that back-end complexity, back-end sales integration is challenging as well. And I'm not even getting to the part where the manufacturer goes away. On the other hand, there's the manufacturer's complexity, and then there's the customer complexity. And the customer complexity goes absolutely the other way. So if the manufacturer's done all of this, it's going to make the experience for the customer a lot easier, because the customer then doesn't need to go scan in labels or anything like that. All he has to do is plug the thing in, and the device will contact the manufacturer, and the manufacturer will say, ah, yes, Eliot owns that device. Right? So that's great. If I have to scan labels, that's more work for me to do. And if I have to do anything else more manually, that's more work for me to do. So this is a challenge because we don't exactly have an alignment in terms of incentives. So we have some economics issues here that we might have to work through. And it's not technology that normally stops things from being deployed, it's economics. All right, so here's all the drafts that are being talked about. So Michael and Max are just finishing up the work on this one here. It's really good stuff. The core RFC 8366 that has the voucher, that's done. Isn't that nice? Okay, Owen Friel, my colleague, has laid out some of the options for how this stuff will work. He doesn't do it in a specification form, he just talks about it. I worked on him with that. Here's the extension for EAP to do a lot of this voucher transfer. We do this right, if we do this EAP thing right, then what that means is that it'll incorporate some of these functions too in terms of the proof of possession. But we want to make sure that we handle all these, as many of these scenarios, right, as we can handle in the smallest amount of protocol and code, especially at the device level, right? One of the things here, right, is if we do the label scanning where the manufacturer tests ownership, there's almost no footprint on this thing at all because it doesn't even need to know its key. Ain't that the cool thing? It doesn't need to know its key, just stick it on a label. So, but we have to make all that work, in a small amount of code. So those are the challenges I have. And with that, I want to thank you for being able to present here in Bangalore again. It's the only place I travel to where I can get a decent cup of tea. So with that, any questions? Please. Oh, by the way, before the questions start, I just want to say there are open issues here, right? I don't claim to have the corner on wisdom. I've come 5,000 miles to tell you that I don't know everything, okay, which I don't. Okay, so I hope you know some more. So please contribute to all of this and add to your own. There's lots of room here for innovation that you can participate in. And I did say I would talk about mailing lists. I will after the questions if Dhruv allows me just a moment. Go on.
Yeah, so zero-touch provisioning.
As we do with the ITF, start with your
name. My name is Kaushik. I work for Juniper Cloud Services.
Okay.
And my question to you is that the zero-touch provisioning or device cloud-based onboarding, right? It's a reality today. It's being done particularly for the CP devices and all, right? That is a typical SD-WAN application. So what is fundamentally different when you onboard an IoT device compared to a CP device in the process of how you do a provisioning for that?
It's really quite simple. If we focus down on the wired versus wireless, which is really the issue here, if you're in a wired device, you know what network you're connected to because you're plugged into it. Okay? In a wireless environment, you got to start by figuring out, you got a menu of 25 networks to join. Which one is the one to join? And so that part, right, if you don't have sales integration, there's no approach to that I think will solve this, right? Regardless of the technology, zero touch or whatever. And I think the one reason that Kent was involved, right, was that he used the voucher as part of zero touch provisioning. Yeah. Right? So we're building on that work. Right? It's not we don't have to start from scratch. We're standing on shoulders, not on backs. Thiru.
McAfee. How do you deal with infected IoT devices or infected registers? That keeps happening in home networks, right? We see all the time IoT devices get infected. Even home routers are nowadays getting infected because they have a lot of vulnerabilities. Mm-hmm. How do you deal with those kind of devices attacking Masa, or basically joining different registers, or registrar trying to take advantage and make the IoT devices join them, and those kind of problems, right?
Okay, Tiro, you have to say who you work for.
I work for McAfee.
Okay, good that you said that, because what I'm going to say is, no, how do you deal with that? I'm willing to, let's make sure that we don't boil the ocean in any one solution, right? So what I need to address is to say, okay, we need to deal with DDoS or DOS attacks on each of the componentry in the system. I have a premise here. My premise is that actually these small devices, IoT devices, shouldn't be listening at all for anything. They should be generating requests. So the only thing that needs to deal with the two attack surfaces then, which is the registrar, which that we do have to deal with, and some of that is just control plane policing and things like that, and masking out different devices, and then there's the Masa itself in the cloud. That has to deal with the DOS attacks as well. And just like any other service, you got to apply basically the same principles. There's no magic, I'm afraid. Michael.
Michael Richardson, Sandelman SoftwareWorks. So I like your slide with all the different options. It's very interesting, and I found you I'm more happy about DPP than I think you are. But even though I really don't like the Wi-Fi's alliance approach to the whole process, but the biggest problem I have is that DPP seems impossible to deploy on smartphones, and because we don't have APIs that let us generate these magic packets. And as far as I can see, Google's got Thread, and Apple's got HomeKit, and I don't see them providing the APIs we need, and we can't do it without super user on those devices. And so DPP is never going to happen on a smartphone, and since it's never going to happen on a smartphone for 5 or 6 years, that sort of crosses it off to me, unfortunately. And while we can make it work on light bulbs and routers, which is great, that eliminates the possibility that the registrar is on your smartphone when you deploy, without internet or something like that. And so I think that's I think it could be solved, but I think that we somehow have to come up with yet another protocol that is the hybrid of all the previous ones. So
I only have a comment on that, which is I think that the community, I don't think Cisco, I work for Cisco. Okay, full disclosure, I work for Cisco. I don't claim that Cisco has all the answers on this question. And even if we had all the answers on this question, everybody else would have all the answers too. And so the problem is that everybody has different answers. And so I think we as a community need to be thinking about what the right thing is. This is the point of standards organizations like the IETF and the IEEE. And if we are able to consolidate our thinking, I believe that Apple and Google will make the interfaces necessary available in order to implement. But we have to, I think, consolidate our view on this. And right now, we're not consolidated. That's why that chart is so wide in terms of its view. Next, please.
Adarsh here. So I have a specific question related to an onboarding purpose. Okay. So while onboarding, it's a wonderful presentation with an WPS serial number and all. So I want to know if multiple local area networks are there. At the time, my end devices, IoT specifically. So when the end devices were doing the switching, so from one local area network to the device is switching to the another network. So is there any specific security onboarding, means from one while hopping is going on?
You mean if the device wants to onboard to multiple networks?
Yes.
If the device wants to first of all, you're talking about so let's put those in more stark terms. That's a mobile device. Yup, that means that the other network has to have that key, or there has to be some form of permissions module in the Masa to say, hey, this is a mobile device, just let it join wherever it's going to join. But The moment you start talking in those terms, right, if it's mobile, choose network selection, again, becomes a problem. And your choice is either proof of possession for the thing or sales integration. And those aren't, they may not be great choices. The good news, such that it's good, is that mobile devices mostly have some sort of interface on them such that you can do some sort of network selection along these lines. Not always, right? And there is room for 5G in this space, which makes that a little easier, where you pre-provision the identity and there's a whole federation model. And we shouldn't exclude 5G in those environments for mobile. And there's other technologies that are going to crop up to do the same thing for wireless, but it's going to take a little longer.
This is Praneeth here. I work at SmartRun Hyderabad. And I have a follow-up question. Is there anything specifically in the handshaking scenario happening in this regard related to onboarding security?
Which handshaking in that case?
The first connection process, DIS.
Okay, so down at the IEEE level, right? At the IEEE level, there's going to need to be probe messages, and I didn't talk about that today, but it is something that needs to happen. So, all right, one last point. Mailing lists. So thanks for letting me draw this out a little bit. So the first mailing list that I want to bring to your attention is the Anima mailing list, where some of this is being talked about. EMU is the other mailing list where we're talking about EAP extensions. And then this draft here is new, and that we're going to talk about in the Ops Area Working Group, and also a little bit in EMU. And that's Ops AWG. And if you go to the IETF website, you can go to the mailing lists and join. I hope everybody participates remotely if you're not showing up, and I wish you a very great conference, and I'll see you later.
Thank you, Eliot. Thank you.